Hi, my name is David Wyban, and I'm an applications engineer with Keithley Instruments. Today I'm going to show you how to use our free TSP Express software to combine two Model 2651A high-power SourceMeter instruments to source a 100 amp current pulse. I'm also going to show you how to use the 18-bit fast ADC to simultaneously digitize both the voltage and the current of the 100 amp pulse. Let me demonstrate. The first thing we need to do is connect our instruments together via TSP link. We do this by simply using a standard Cat5e crossover Ethernet cable. The next thing we need to do is connect our instrument to our computer via Ethernet, and we do this again using a standard Cat5e crossover Ethernet cable. Finally, we need to connect the output of our instruments to the device. We connect the force leads of our instruments using the supplied Keithley high current coaxial cables. We connect the sense leads by using the Model 2600-BAN test lead kit. For this demonstration, I'll be using a 75 milliohm resistor. I simply connect my test leads to the device, connecting my sense leads as close to the device as possible to minimize the error due to voltage drop in the test leads. Note that I've connected the outputs of my SMUs together in parallel using some jumper wires connected between the screw terminals. We are now ready to load up TSP Express and begin our test. To launch TSP Express, first start by opening your web browser. Enter the IP address of the instrument into the address bar and then press Enter. In the navigation pane on the left, click TSP Express. Click the big Launch button to launch TSP Express. After TSP Express loads, you'll be presented with the welcome screen, which has some quick start projects and tools in the middle. Alright, now let me maximize this window so we can get a better view. After TSP Express loads, you'll be presented with this welcome screen here, and you can see some quick start projects and some tools in the middle. For most tests, it's easiest to start with the single smooth sweeps and measurements project and modify it, so let's start by clicking that. Now the project loads with the SMUs already assigned. We want to change this, so let's do this by clicking the SMU assignment button. First we need to unassign the SMUs, so let's do this by selecting each SMU and then clicking the left arrow to unassign it. Now to pulse 100 amps, we first need to combine our SMUs together, so TSP Express will treat them as a single SMU. To do this, click the Combine SMUs button. The SMU combining window opens, and here we can select the SMUs to be combined. We only have two in here, so let's combine them. Select the first one from the list and click the right arrow to add it to the combination. Then repeat for the second one. We will be combining these SMUs in parallel, so let's click the Combine button. A window will pop up with a diagram showing the proper connections for this combination. Click Close to dismiss this window and go back to the SMU combining window. We can now see that a new composite SMU has been added to the list of composite SMUs. Click OK to close this window and go back to the SMU assignment window. In the SMU assignment window, we now see, instead of two SMUs listed, a single composite SMU. Select the composite SMU and assign it to the sweep segment by clicking the right arrow. Click OK to accept. When we look at the channel configuration, we can see that our new composite SMU is assigned to the sweep segment and that the source function is current. For this demonstration, we want to digitize both the voltage and current waveforms of the pulse, so for the measure function, select current and voltage. To configure the pulse, move down to the sweep configuration. To source a 100 amp pulse, first select the 100 amp range. Then set the start and stop values to 100 amps each. For 100 amps through a 75 milliohm resistor, we expect a voltage of about 7.5 volts, so let's select the 10 volt range for the measurement. Now we only want to digitize a single pulse, so let's change the number of points to 1. Next we'll set the pulse width. Let's drop it down to 300 microseconds. Finally, we need to set the voltage sense mode and voltage limit. To do this, go back up to the channel configuration and click the Advanced button. Change the sense mode to 4-wire, then change the voltage limit to 10 volts. Click OK to accept. At this point, our source is set up, but we still need to configure our measurements. To do this, click the timing button in the upper left. The first tab configures the integrating ADC settings. However, we want to digitize the pulse. To do this, first select the second tab, and then select high-speed sampling. Leave the sampling interval at 1 microsecond and change the sampling count to 500. Click OK to accept. We have now configured our project and are ready to run the test. To run the test, simply click the green Run button at the top of the screen. As you can see on the scope, the pulse was output, and upon closer examination we could see that it reached 100 amps. Let's switch over to the Data tab and take a look at the measurements. On the Data tab, we can see the data in a tabular format, and we can easily export this data to CSV file for later analysis in Microsoft Excel, simply by clicking the Export button at the bottom. We can also graph this data directly in TSP Express. To do this, simply change the display type to Graph. In this plot, we have timestamps on the x-axis and current readings on the y-axis, very clearly showing the digitized current waveform. In the plot, we see the pulse rise to 100 amps, settle, and then drop back down to 0 at the end. Keep in mind that these are 18-bit readings, so the data behind this plot is very accurate. Now let's switch the y-axis to voltage readings. To do this, select the y-axis drop-down, and then select Sweep SMU Readings Volts. Again, we see the pulse rise, we see it settle at 7.5 volts, as we expected, and then we see it fall back down to 0 again. So just like that, we were able to combine two SMUs to produce a 100 amp pulse and digitize the current and voltage waveforms. TSP Express makes this easy to do without having to write a single line of code. I hope that you've enjoyed this demonstration. For more information, please click the link at the end of this video. Thanks for watching.